University will deliver a talk on Geospatial Intelligence 2.0, tackling the climate crisis through sustainable resource management and resilient communities. Dr. Manoranjan Mishra is a professor in the Department of Geography at Fakir Mohun University, where he has been serving since 2022. Dr. Mishra's research expertise lies at the intersection of geospatial technologies and natural resource management, with a particular focus on understanding the impacts of extreme events on coastal and environmental systems. His work has significantly contributed to advancing knowledge on climate-induced hazards, coastal vulnerability, and risk assessment. I invite you, sir, to kindly deliver the talk.
Okay, so very good afternoon to everyone. I think after lunch session usually is something like, nobody is comfortable, but still I will make the session short and some kind of, journey which I will be showing, which I am doing last, 15 years. But 2022, I think we are into some system, some extreme events which we are working at the last mile. So I'll show you the experience of all these things. Before I go to my slide, I will just ask, what's a simple question? What is, the crisis or the problem which the planet Earth is facing right now? Can anybody say, is it like climate crisis?
Rising the temperature, I think.
Yeah. So you see, if I see like this, if I see there is climate crisis, food insecurity, then there are water crisis, a lot of disasters are coming up. So if I come off, there are three questions which is coming up: where it is happening, so whom it is affecting, like what community is affected, okay, and then how it is spreading. If you see, all these things are related to three things. One is space, that's called as place or time, okay. Third thing is like pattern, okay. So these three, are the critical things when you are looking at the nature. If I am looking at the nature, looking at particular system, okay, what I look into how it is changing in space and time, and what is the pattern inside it. Is there any pattern? And if I see, I work with many systems. I work with coastal systems, I work with atmosphere, with a lot of extreme events. What I see, the Earth is a very dynamic planet, which you see one of the animations showing, they are interconnected. Okay? And second thing is, so always they are tending to equilibrium. So, what I am trying to say, like where, geo-intelligence or geospatial intelligence come into existence, because when you are looking at these things, okay, means looking at a system, it's not a static system. What geospatial technology usually we do, we create a map which is very static in nature. But it is a living system. This is an interconnected one. When you look into ground zero, if I can ask you, like one of the critical events which is happening in India is lightning. Can I save a life at a point? So there where you don't create maps, you have to use geospatial technology. Another thing I'll just put into this climate change, the kind of debate, discourse going on. Whenever we say climate change, people talk about it is all about increase in temperature, change in precipitation pattern. We talk at 1 degree temperature, 1.5 degree temperature. But when I work at the ground reality, I think in a different way. I think, like if there is an increase in 1 degree maximum temperature in a particular local region also, so what will happen? So 1 degree increase in maximum temperature, the thing will, if there is a like moisture is available, or you can say Bay of Bengal is there, if I can say what exactly is happening in the eastern coast of India or the state like Odisha and Jharkhand, 1 degree increase in maximum temperature in pre-monsoon means 7 to 14% moisture is added. Once this moisture will added, so what will happen? So it has a teleconnection with El Nino, IOD and everything. Because, this will affect the sea breeze and land breeze. I'll just say you, the year where there is more moisture, means, the wind blows from the sea to the land, so you will have more lightning activity. The year when land is more heated and, the wind blows from the land to the sea, so it is a heat wave condition. And every alternative year you have these conditions. And this is going to intensify in coming days. So what I say, if there is an increase in 1 degree maximum temperature, there will be a lot of changes which will happen, which I will show you few of the findings. Yes, it's not moving. Okay, you can see what is exactly is happening right now in the global scale. Our system is moving from Holocene to Anthropocene. I'll just see what exactly is happening. We are moving to the age of human being, where there is a reduction in resilience, okay? And the living system inside this particular Earth system, if it wants to be exist, so it has to play a safe game. There is a paper in Nature which says there is 9 planetary boundaries, with 3 planetary boundaries we have crossed, still we have to play a safe game. But still, I put a question like this: if I go back to Cretaceous period, in geological time, the amount of carbon dioxide was 20 times what is existing right now. Still life was existing. That you can see the dinosaurs and everything was there. So if you see in geological time, 4.6 billion years, 58 minutes, if I convert it into 1 hour, there was no human being. Still 5 mass extinction happened. We are now in the early stage of 6 mass extinction. So climate crisis or climate change is a natural process. But the only issue is, so right now, due to these anthropogenic activities, still a lot of evidence has to be created, so we are, in a faster mode or accelerating mode. So that is why the events which was happening before rarely, right now become new normal. Okay? Okay, so when I talk about geospatial intelligence, I think everybody knows what is geospatial. Okay? I put intelligence because the reason is very simple. Like when I say, means it's like something which is data driven but predictive analytics. What I think, like the things which is happening right now in 21st century, before you generations, there are a lot of uncertainties, complexities are coming up. So these kind of intelligence, whatever data you are producing, or if you can connect to the decision making process, understanding the concepts and make it useful or make it analytical. I'll show you with a few of my works also next. Oh, chalo. Okay, so this is called as age of geospatial intelligence. I just want to say a few things about that. When I say 2.0, it's a different one. So people like me who is working in a very small university, in Baleshwar, so usually why it is required? The geospatial intelligence, why it is required? So I am working very close to the ground, you can say to the field, which is happening in ground reality. I am in the coast, I see the changes, okay? So whenever I run a model, so I have a limitation of data. Okay, first of all, I have a lot of limitation when I look at the coastal process. Dubedi sir is working, we work with 5 years or 1 year, but it changes, every day it changes, and in 2 kilometers the process changes. Okay, so if I want to run a model on that, so it will not fit into that. Even if an atmospheric model, Panda sir is there, like when we do lightning forecasting, so it is only 30% accuracy. Even if we put 200 crores in same RWF put it, but still it's only 30% in pre-monsoon, 60 to 70%, in a monsoon, okay, and maybe 60 to 70 in post-monsoon also. So what I am trying to say, the reason is we are not getting the real-time data with the changes which is happening at the ground level. The next thing which is available with me is to looking into the pattern. As I am looking into the nature always tends to some kind of pattern. Okay, if I can look into that, then I train my machine, which I think in the morning there was a lot of discussion going on machine learning, AI, all these things. There are, like when I use machine learning, what I do, I take ground zero, patterns. then I put into the machine, I trained it. So the accuracy will increase. And my understanding looking into these things will will increase. I'll show you how things are happening with one example, which I got a project. Okay, I know that it will not give any result. Still there are other ways, but still the funding agency, I cannot make them understand this is not the right way, okay, if you are approaching these particular disaster. But still, to get my fund, I have to do that. But if I look into the real thing, it's a different one. I'll show you that also. So whenever I say geospatial intelligence, obviously it is integration of AI, cloud computing, mobile platform, enhanced visualization. These are things which you have to look into. As a geospatial expert, it's all, means whenever I create anything, okay, it is something which can tell its own story. I don't require to write text about it. Okay, so that is as a geospatial intelligence means it's all about telling your story. Whatever you create the product, it will tell the story. You don't require to stand there and to tell the story. Okay. Sorry. Okay, I'll just show you some issues. I think 2 of our works which we are under review. I'll just put in AI and I have done. Okay, so whenever you are working with atmospheric model, okay, so there are, millions of data are available. So when I look into the pattern, so the quality of data which is available, maybe the resolutions are different. So if I go for a longer time period, okay, I can get a, more, different trains or patterns into that. So if anybody is working on, climate systems, 110 years data, the grid data, IMD data is available, temperature, rainfall, even if you can create moisture, then there are a lot of reanalysis data, a lot of data are available. It's just used to play with the game, but the real thing is, you should develop the fundamental concept, what you are really working, how they are interacting, okay, that is very important. Then you look into pattern. It's not like you don't understand, you create a pattern, so you know what the machine will give a, machine learning is like, it's a black box. Input, you get an output. If you put coal, so obviously you get, maybe you get diamond. But if you put kachara, then kachara will be out. So that is why it's very important, you to connect with the ground. Your sir was talking about validation, calibration, these are things which you have to put. Okay? Then I think there are, a number of things which is available right now in open source platforms. So that is why right now you don't require huge investments. Even if my lab, small lab can produce many things. Okay, we can do because many things are open sources. You don't require high-end computing. But if you want to run a model, you require a workstation. Okay, but if you work with the machine learning in different cloud platforms, a lot of options are available. You should just know how to communicate with the programming language. Then I'll just show some applications. This is one paper which we have done. I have just put in AI because the paper is under review. You can see what we have done. We try to understand, 1994, 2024. So what is the impact of climate climate crisis or climate change in agroclimatic region? You can see there is a temperature rise of 0.15 to 0.1 degree. You can see there is a, the impact are differential. And the main thing is, you can see there is a declining rainfall in plateau region. Coastal zones have erratic rainfall, rising heat temperature. Still, you can see soil moisture decline since 2018. So these are things which, if I want to do a prediction, what will happen, to the agricultural productivity, we have done another paper also. You can see there is a huge impact. Still, we have to think in this direction, because whenever government is coming off with some policy, like minimum support price kind of things, so they have to think in this direction also. The productivity will be reduced in coming days. But still, there are other ways you have to go for adaptation. I am not going in details. I think this paper is under review. Then I will just go to these extreme events. This is one which I really work hard for these things. This is about the lightning. I think you must be knowing in India, almost every year 2,800 to 3,500 people die. And in Odisha also, there are almost 287 people die. But still, what we have done, I can show you what is I was talking about this thing. You can see in the upper part, this is about the death. This is a paper we published in Current Science. What we have shown, after 2000, after 99 supercyclone in Odisha, almost 71% death was due to lightning. 21% is heat wave. The reason there is a difference in death is because in case of lightning, compensation is given. So every death is recorded, postmortem is done. But in case of heat wave, it is not happening. Okay, so this is the first impact. Every year, so either you will have more lightning activity or a heat wave kind of condition, and things are connected is not with the local conditions. It is connected with teleconnections. Either El Nino, La Nina, IoT, a lot of things are happening. These are connected with that. Then the local phenomena used to play. And if you see in the state which is nearby, that is Bihar, 440% increase in death. Single day, 118 days, 120 days, these kind of things happening. We just try to, understand the class. You can see there are, I was talking about space and time, you can see there is a clusters. Okay? And there are a number of triggering factors for it. We are trying to understand what is the triggering factors for, the northeast part of India, or maybe, central India. What we find, in case of death, the central India is having maximum death. Okay? And the northwest India is having less death. You can see the recipe for lightning activity is temperature and moisture. First important criteria. And as Bay of Bengal is there, we get moisture. And heating is there. And if it is a convection plane, so convection process happen. When the moisture incurs from the sea towards the plane, so what will happen? Where there is an elevation, it will just push it. So what will happen? So more high intensity activity happen. The cloud will happen, black cloud kind of things will happen. Then these are things. And other thing you can see here, so almost 1 lakh people have died in the last 69 years. And in the last 2 decades, there is an increase in death. From on an average it was 1800, right now it is 2800 to 3500. You can see this is, I was talking about the state which is affected. So there are a lot of teleconnection. I was talking about La Nina, strong positive IoT. This is also a paper which we have communicated. And sorry. You can see this is one I was just talking about geospatial intelligence. As a researcher, I ask these questions. I am just giving you 4 case studies which you can just think of how to get a solution. Is it a solution means what I am talking about? Is it for some publication? Or is it something which is for the society or policy kind of things? I am just putting, this research I started because of one of my students was died in my campus. I was in Berhampur University. I'm just talking about space, time and action. You just think of what we called it as a trio, Sthana, Kala and Patra. Just think 2 students just finished their end semester exam, and at 5 o'clock my university is close to the sea. So 1 boy and 1 girl went to the seaside. This was just the end of the semester. So what happened? The weather was very fair. Suddenly it changes. One lightning activity will strike the sea, and the boy was talking with his Bluetooth. It was blasted, sudden death, and girl was injured critically because she was wearing gold. Okay, that's metal which attracted. Then second one, you can see, just think of this year, last 2025 in Moirvanj, there was a farmer family which is working at 2 o'clock in agricultural field. This is, monsoon time. That was pre-monsoon time, this is monsoon time. And what exactly happened? The rainfall started, so the cloud was formed. So what exactly happened? So the farmer family decided to go back home. So they were just wrapping up. There were one husband, wife and 2 kids. What happened? The 2 kids started running. Okay, the wife started running before them, and the lightning strike, the male member or the husband was killed at that point. Just, 20 to 30 meter difference. Just think of 20 to 30 meter difference. Someone was killed and other were saved. Then third one was like, this is pre-monsoon, this is in Puri. What exactly happened? Like parents, there was a young guy, they went for watering vegetable farms, they were putting water there. So what happened? Lightning strike. So the the young guy was killed, the father and mother were seen, just, their kids just fall and has died. Just, I think, 10 to 20 meter difference. Only thing, he was using water. Okay? So, I just asked myself, if I go back 30 minutes before, okay, can I give a certain information which can save his life? Or maybe 1 hour before. Is there any technology, if it's given to me, so can I save these lives? So there, the question I think is to all and to me also. So I just worked on this thing. I'll show you what I exactly look into. You see, whenever I look into, whenever the information is coming, whatever early warning system or forecasting is done, it is called as, the atmospheric instability. Temperature, rainfall, okay. And there are number of other parameters like K, CIN, cloud, all these things, okay. Then they run a model. And just, 25, there is nowcasting, there is forecasting, these things IMD come, okay. But the problem is, so the date which is happening is at a point. But the forecasting is done in a very general way, for a district. Okay? Point one. Second point is, there are a lot of uncertainties when I run the model. That is why, the changes which is happening vertically, so it changes, 3 minutes, 4 minutes, 5 minutes, we don't put into the model. So that's why it doesn't work. Again, the upper atmosphere data, there is a lot of limitations. Like Cape, CIN, we don't get input data every time. Okay? It comes up in a, for a week. Then another thing, once it pumps the cloud physics, so there are a lot of uncertainties or the, interaction, then it pumps into, lightning. Again, lightnings, 85% of the activity happen in the sky, which is called cloud-to-cloud activities, or cloud-to-cloud lightning activity. But only 10 to 15% comes down. Again, it is two types. When it comes down, these are charged particles which is coming up. Negative charge electron is coming off, and during that time, everything on the Earth's surface becomes positive. Then that negative charge will connect, if it is a negative CG, it will connect with a suitable, positive charge. So suitable means there are 50 people, it will connect with a single one, which is suitable. But it will try to connect with a positive charge, give a huge amount of electric shock so that it can discharge at the ground. So typically a lightning activity is 3 lakh volt of electric current. So for choosing this, you just think of, our forecasting is atmospheric instability. But the electron which is choosing, it is choosing a suitable one. So what kind of information can save his life? So that is why, even if we go for 0.05 into 0.05 kind of, spatial resolution, it cannot save life. Because the death is happening at a point, then the electron chooses a suitable one. But when it comes to positive CG, it's more dangerous. So what it happens, the electrons will be static. So it will try to pull positive charges. While pulling, so it requires 10 to 12 features it will pull. So that is why in a single activity, 10 to 13 or 14 people die, that's mostly positive CG. But when it happens negative CG, just 1 people it will, it will do that. Okay, so what exactly we do, what we try, I got a project on that, on forecasting, from the, NRSC. So how to increase the, we have a plan for that, but still I am not, can guarantee that whatever information I produce that can save life. But still, funding agency want that our spatial resolution should increase. But what we try, what we are looking into, if I look into why, death in Orissa is high, it's almost more than USA, whole country. It's almost equal to China, 300. Okay, so I just think of, it's all exposure. And I look into what is the space, what is the time. So we map, in space and time. In pre-monsoon, which are the places, is there any pattern where the activity is happening? We found a pattern. But when we go to time, it's quite interesting. Most of the activities start after, 12 o'clock. Because the convection process takes half an hour to 3 hours. So then, I'll finish. Okay. 5 minutes is difficult. Okay. Most of the convection process happens after, 12 o'clock. It takes peaks at 1 o'clock. And at 3 o'clock, so what will happen? From 2 to 7, most of the death is happening. But the lightning activity is happening from 12 o'clock afternoon till 12 o'clock night. But after 7 o'clock, there is no death. what we have seen from the death data. So the window is mostly is from 2 to 7. If the people who are killed are targeted people. The people who are killed is like farmers, grazers, laborers, construction workers. If whatever policy I can bring or whatever last mile connectivity I do, I just change their behavior. Looking at the pattern, you don't go to the agricultural field. You remain in your house. So the risk is only 10%. If it is a kacha house, there is a chance of death. But if it is, semi-Faraday case house, you are completely safe. If it is, a brick or without semi-Faraday case, so the chances of injury is there, death is less. So that is why my first choice, which I presented many places, I said, if we can just in the pre-monsoon, you have to the temperature is quite high, so 4 to 6 people goes up and death happens. But when I go to the monsoon, I find a pattern like there are wet period, there are dry period. Right now, the monsoon is erratic. So whenever the month means the year which is having more dry period, so more lightning activity. So the transition period is more active. So that is the period we can just ask the farmer, you do your work before 1 o'clock, don't go to the agricultural field. Your life will be saved. Okay. So there are, I think we have learned a lot of machine learning into that. We don't have a time to speak. This is what we created, the time one. You can see here. This is one I think we created using Python. So we created from the flash data in the last 20 years TRM MLIS, or you can say we used there is NRSE LIS or LDS, IIT Pune LDS 2019 to 2025. You can see most of the activity which is happening, and this is what we have created for a village. I can identify which region is vulnerable, which region is safe, and I can just translate these to the people who are at high risk. Not you and me, people like are not at a high risk because our exposure is less outside, but the chances of 10% death is also there. When you are going back to your office, the chances is quite high. So whenever lightning is happening, so try to stay in a semi-Faraday case house at least half an hour before the lightning activity stops in the sky, because convection process stops when there is no lightning activity for half an hour. So we are trying to do lots of last mile connectivity. So this is one work which we have done for Bihar, because every year there is a death in the pre-monsoon and post-monsoon. What we found, there are two things which is controlling. One is called as K, another is CIA. These are the two parameters, because what is happening when there is a highly hitting in Bihar, so when the monsoon is entering, means in the from the transition period, from the summer, it's just in the month of June. So what is exactly happening? It is like a lightning hot rod. So what will happen when the moisture will come up? So there will be convective available potential energy. It's like a pressure. When you just look at pressure, there is a temperature you are giving, pressure is building up. The nozzle is convective innovative. So if it is weak, so what will happen? It will start moving up. So the more it moves up, so the more high intensity activity. In single day, 27,000 CG happened. Almost 100 people died. And what we found, so the highest lightning activity happened in Ara, but the death was 0. Because the time was 3 to 7 o'clock. So that is why I said space, time, and pattern actions, which is very important to integrate in geospatial intelligence. I'll just show a few of our works which we have done. I think I'll just escape. These are the drought we are working. We have published these papers in drought for 120 years using machine learning. This is a paper we worked in forest fires, which we look into space and time. What we found that there is a reduction, in the moisture in the pre-monsoon period, which is leading to a lot of, increase in, forest fire in some areas. And then this is the coastal disaster. I think we work a lot on this. What we found in coast, it's not the nature which is making changes, it's the human being. So what exactly happening? So there are a lot of construction of embankments. So every river which is dumping sediments and water inside the sea has reduced exponentially. So what will happen? So obviously the sea forces will be dominant, and they are, a lot of coastal erosion is happening. It is happening at the mouth places. Next place is the ports, where the wave breaker is just like perpendicular. So whenever literal drifts are coming up, so it is clogged at these points. So there is a erosion in northern side and there deposition in southern side. So then it is affecting the whole coastline. You can see there we have done this paper, you can go through this. And this is on sea level rise. I think there are a lot of debates going on sea level rise, but still a lot of validated kind of works has to be done. A lot of scenario modelings are being done. And in Orissa, number of villages are inside sea. You can see we can find many, at least 10 to 12 villages are right now inside, and in coming days more villages will be inside sea. Okay, so then again, what we look into the interaction between these, the wildlife, how they, whatever changes is happening in the system, so how it is affecting. This is one, I think, this is a very interesting creature which is called as, Olivrilli turtle. So every year it moves from the Odisha coast to Sri Lankan coast, again comes back to give egg at a particular time period. So it has a eco-physical conditions. So they perceive the condition. So there are a number of triggering factors which they perceive, then they go for mass nesting or sparse nesting or false nesting. So these three conditions they do, and there is a very they understand the changes easily. And if you find in Orissa there are 3 nesting sites. The highest was Gahir Mata, which was eroded right now. So they have moved to the Dhamara coast or the Wheeler Island where the missile is coming up. Then the next is Rusikulya, Devi. So there is you can find interesting things, how they perceive nature, how they perceive the anthropogenic changes, and then they go for their life cycle. Okay, so this is quite interesting. We look into. And
they are migrating from these areas, no?
Every year one group, there are different groups are there. So one group is coming from Sri Lanka, another is coming from Maldives. So they will come along the coastline, along the slope of the the currents which is flowing. Then at December they will come, they will start mating. Then at a particular temperature, when there is a high wave, this is a very lazy animal. So when they are pushed to the coast, then they will look into fine sediments. Then they will give egg, and they don't stay there for their kids. They again once they give egg, they will start swimming. So the hatchling will happen. When the baby, what it will do, it will crawl into the sea. Again, he or she will start swimming and go with them. Okay, so that is why there are a lot of things that you can look into, very quite interesting things. Then we look into another interesting thing is Bhitarkanika. That's crocodile. So there is also there is over conservation. There are many over conservation done. What happened? We artificially breeded this crocodile, and there is a carrying capacity of that particular biosphere reserve is 1500. So right now 2500 crocodiles are there. So where they will go? So what they are doing? They are going in the river. Okay, and the beautiful thing is they perceive the cyclone. Where if there is a chance of cyclone in a particular year, so the female will give leg in the higher elevation. When any human beings comes to there, they become violent. Okay, they attack. So a lot of 37 people were killed. So this is about over conservation kind of things. Then I'm just finishing within 2 minutes. I think this is how we will be thinking of as a art scientist or geospatial experts. There is a demand and supply. The population is increasing like anything. 12 billion we will be reaching. Shortly. Again, the China and India will having 50% population. Okay, so that is why we talk about 2047. We don't talk about right now. This is 2036, 2047, because we will be not. I think I will be not there to think what will happen in 2047. But still, number of changes are happening, and if you are looking for a job, you have to look into what is exactly is going to happen. Industrial Revolution 4, Industrial Revolution 5. Industrial Revolution 4 is man-to-machine communication. Information economy. But the economy which is coming off is knowledge-based economy. It is machine-to-machine communication. It's more automation. It's more intelligence. So that is why it's all about curiosity, creativity, innovations, which will give you a job. Okay, just creating some maps, static maps will not give anything to you. Then, I think whenever we talk about climate change, we have to really think of, that in the morning, sir was talking about looking into nature, acting like nature. Okay, so nature always gives you a threshold. Whenever I work with any system, I always look, is there any pattern, is there phase of equilibrium? When I look into the coastal erosion, there is a phase of erosion, phase of, deposition. So that is why, the funnel is, narrowing down. So we have to act, and we have to act in nature's way. And this is the skill, I think, every, 5 years, if I'm looking at a job, so like AI will be part of you. If you don't accept it, it's up to you. People talk a lot because, machine learning, AI, this will be the coming things which will coming on. Whenever I talk about data, information, knowledge and wisdom, when I say data to information, AI will be taking on. And, like most of the 80% of the programming language right now written by generative AI. And maybe next 5 years, 100% will be written because they will be better than us because they are learning every time. Okay, so whenever I am working, I should be a good prompter. Okay, good designer, because these things will be the reality. I cannot just say that this is a thing which is coming up, I should come out of. I just think of how to utilize it in a better way, to solve the society or something like that. Then for climate, whenever I work with our system, I have to work with all these systems. I cannot work, whenever I say landslide, it's not about atmospheric model, lithology. So you should connect all these systems. You have to look into a system. So that is why climate modeling is an important thing. Whenever you work with our system, without climate models, you cannot work for any solution. So that is why there are a number of, datas are available, models are available, everything is available just to work with that. Then programming, and these are easy things, Python, JavaScript or R. We are talking about, whenever we do visualization, we use 20 to 30 softwares, okay, to create a visualization. That takes a lot of time, okay. So to create impression, and we always keep in the mind, we are in a, fast, furious age. So that is why we don't have time. So whenever I look into, I have to create an impression. So in a paper, the first thing they look into figure and table. So we create that fast with some innovative ways. And then we make a, story which is something new. Okay, maybe some people don't find new, but still we want to create an impact on that, something different. And then visual storytelling, that's very important. I think whenever I make a presentation or as a student, whenever I am, making any product, so it has to tell his own story. I should not be there. Even if I am not there, it doesn't matter. So that is why geospatial intelligence is all about, it's the art of telling stories using, different maps or, animations kind of things. Then this is the last one. I think this is all about, whenever I say geospatial technology, it's not about creating maps, it's a living system. So there a lot of feedbacks has to come. I have to accept that feedbacks, whatever, things which is coming to the ground reality, how to integrate into my models or something looking into different. So whenever I have already done, I think 250, awareness campaign in remote areas in Odisha. So I got lot of, inputs from them. Whenever they give that this is the thing which is happening, then I come up and look into the science. Then we have a discussion. And these inputs can make a difference. So that is why validation, calibration, working at the ground, okay, making difference at the ground is more important, where a lot of innovations are required. So thank you very much.
Thank you so much, sir. Thank you for sharing your valuable and diverse.
Sir, what are the suggestions you will give to the farmers who are working in the field
Agriculture.
during the monsoon season? Yes.
Yeah, the very simple one is, we have to just look into if there is an active rainfall. If the monsoon is very active, okay, 3-4 days rainfall is happening. First day, do not go to agriculture.
Okay.
Day one, okay?
Yes.
Then there will be no activity. When it stops, there is activity. Okay. So if you see the year which is having a active monsoon, there is a less lightning activity. When there is more dry period, so there is more lightning activity. Again, another suggestion is very simple thing which they can do. Always avoid second half. So try to work in the early morning, finish at 1 o'clock. you don't expose yourself. If you don't expose, so there will be no death, because farmer works inside the water. So in the monsoon, the clouds are found at lower height. So the charged particle goes inside the water. So then it becomes electrified, direct electric current. The death happens. So if I am not at that point during that time, so there is less chance of death.
Give a huge round of applause, everyone.
Photographs ले रहे थे.
Thank you so much, sir.
Photo लीजिए. Wait. Photo ले रहे हैं. क्या हुआ?